Hey guys, so today we're going to be talking about inheritance within object-oriented programming. Now, I know this is a concept we've sort of introduced before, but today we're going to take a closer look and take a deeper dive into inheritance, talk about what it is and why it's important to us as software developers. All right, so let's get started. So talking about object-oriented programming, there's often four main pillars or features that are often mentioned. One of them being inheritance, which we're going to talk about today. But the others, just to mention them, are polymorphism, abstraction, and encapsulation. Now, these are all great topics to talk about and learn about, but we're just going to focus on inheritance for today. So let's proceed. Now, the first question you guys might have is, what is inheritance? So luckily, I think most of us have a good general understanding of what inheritance is in our real world or daily lives. We can think of it as, maybe something that we get from our parents or grandparents, whether it be money that we inherit or family heirlooms that are passed down from generation to generation. Also, I think we also are familiar with it in a biological sense, where we inherit traits from our parents, for example, eye color or hair color or things of that nature. So yeah, I think we have a good understanding of what inheritance is, and luckily it's not too different in the object-oriented programming sense. So let's talk more about that. So to give a formal definition of inheritance within OOP, we could define it as a mechanism where properties, in this case properties are attributes or methods from classes that are passed down to derived classes automatically. So to state that another way, if we wanted to, we could say that derived classes inherit properties from base classes. And just so you're familiar with other terminology that's often used, we could also use parent classes and child classes, where instead of saying derived, we could say child classes, and instead of saying base classes, we could say parent classes. So it's those are generally interchangeable, but for this lecture, I'm going to be mostly focusing on saying derived classes and base classes. All right. So now that we know sort of what inheritance is, I think the next sensible question is, why do we care about it? And there's many features that inheritance offers us as developers. One of them is to establish relationships between classes. Now, in our class introduction, we've talked about that classes are often used to represent real world objects, and to model those relationships. Like real world objects have relationships. For example, you may have a laptop computer and a desktop computer. Now, both of those are types of computers, and they have many similar features and properties. So to reflect that in our software, we would create classes and then inherit from maybe a generic computer class, and then create a laptop class and a desktop class where the shared attributes or methods, I guess, that are common to both are stored in our computer class, whereas the differences between laptops and desktops would be more specific to each individual class, laptop or desktop class, depending on what we're implementing. Another reason inheritance is very useful is that it reduces repeated code. And now we've talked about the DRY principle, DRY, which stands for don't repeat yourself. And yeah, so inheritance kind of automatically lets us implement that that idea where we could reuse our code based on, if there are shared properties or shared methods, we could kind of bundle that up in more base classes and kind of reduce the amount of code that we need to maintain for our derived classes. Another reason we want inheritance is that it allows making changes to our code much more seamless and much more consistent. And instead of having to update maybe like 15 different classes that we may have created, if we are able to structure our class definitions such that they inherit from more generic base classes, it'd be much easier, for example, to just update maybe one or two base classes and have the properties, whether it be attributes or methods, kind of trickle down to all of our derived classes. So it just kind of reduces the maintenance there and makes life a bit more easier as a software developer. So yeah, there's just a few reasons why inheritance is quite useful for development purposes. Now let's talk about how we actually use inheritance within Python. So it's quite simple. again, we've probably seen that syntax before, but just to be more clear about it, we create a base class. We can name it, whatever we want. And if we want to inherit from it, we pass it in parentheses to a derived class that we might create. So if you want to just see a quick coding example of this, let's create some simple classes for our sake. I'm going to create a class. I'm going to call it shape. So I give the name of shape, put my colon, and then let's create a simple init method. So don't forget to pass your self parameter as the first parameter. Always easy to forget that. In this case, I'll take in a name, and then I'll store that name as an instance attribute and assign it like so. All right, so that is my simple shape class, nothing fancy going on there. And now I'm going to create a derived class that I want to inherit from the shape class. So in this case, I'm going to call it triangle, and then I'm going to inherit from the shape class. So just to point out the syntax, I name my class, and then in parentheses, I pass in the name of the class that I want to inherit from. So in this case, the shape class is not inheriting from anything. So in this case, the parentheses here are optional because there's nothing to inherit from. However, if you do want to inherit, you have to use parentheses to define what you're inheriting from. So in this case, the triangle class is a base class. Sorry, the triangle class is a derived class inheriting from a base class, which is our shape class in this case. We could also say the triangle class is a child class of the shape class, which is a parent class. But just to be more consistent, I'm going to be saying derived and base classes more often. All right, so we have a simple example. So just to see how inheritance is kind of working here, let's create a triangle object. So I'm going to create a triangle object from our triangle class. And then I just want to print out, we should probably give it a name, triangle. And then I'm going to simply print out the name for my triangle. So if you notice a couple things, my triangle class here actually has no special definition in it. I just use the pass keyword, which means there's nothing implemented here. However, since we're inheriting from the shape class, that means we get access to all the shape's methods and attributes. So in this case, we're inheriting both the init method and we're inheriting the name instance attribute. So to see this at play, we can simply run this. And let me type in Python and run my file. All right, so we printed out my triangle. So again, just to point this out again, notice that my triangle class has not declared an instance attribute. It's inheriting that from my shape class. Also, I've not declared an init method, but I've still passed in a name parameter to my triangle class, and that is because my triangle class can just use the init method from the shape class. All right, so that's a very simple example. We'll get into more detailed examples going forward. I just wanted to introduce the syntax. Again, we want to use parentheses and then pass in the name of the base class that we want to derive from when we're defining a derived class. So in this case, triangle is a derived class of our shape base class. All right. So, so that's how we use inheritance or employ inheritance in Python. Let's talk about the types of inheritance that you might see or might use in your development. So there's, I guess, 4 main types of inheritance, one of them being single inheritance. And now this is the simplest example. It's actually what we just demonstrated just before in our coding example. Single inheritance, then there's multi-level inheritance, multiple inheritance, and then finally hierarchical inheritance. So let's kind of talk about more of these more in detail. All right, so single inheritance. Now this is the simplest kind of inheritance. We actually just saw it, as I said. This is where we have one base class, and we create one derived class from that base class. So in this case, A is our base class, and B is deriving from our base class A, and we just call that our derived class B. All right, so that's the example we just saw. So I don't think I need to create a new example for this, but in this case, shape is our base class, triangle is our derived class. So let's call that our single inheritance. All right, so that's our single inheritance example. Now, actually, let me change this to rectangle just to demonstrate things a little better. All right, so we still have a base class, derived class, and this is our single inheritance example. So now let's go back and talk about the next type of inheritance, multi-level inheritance. So now this is actually just an extension of single inheritance. So in this case, I have a class named A, a class named B, and a class named C. So in this case, A is our base class, and then we derive class B from that. And then from class B, we actually derive class C. So in this case, B is both a derived class and a base class. B is a derived class of class A, but it is actually one of the base classes for class C. So again, we're just creating an extended chain. Again, you can go as many levels as you want. You could go 5, 7, 20 levels deep if you want, if it makes sense. So I guess the sky's the limit in terms of how many times you want to create derived classes in your chain. So that's multi-level inheritance. Let's see an example of that. So going back to my example, I'm going to change my comments to multi-level. All right, so in this case, I'm going to create another class, and I call that class square. In this case, my square class is going to inherit from my rectangle class. And I'm not going to really implement anything here, but just notice kind of what these classes encompass. So a shape is kind of a generic I guess, object or a generic idea. Rectangle is a little more specific. I think we're all familiar with rectangles. They're four-sided. They have 90-degree angles. And then we have a square class. A square class is actually, a square is actually a type of rectangle, but it's a special type of rectangle. So in this case, we create a more specialized class and derive that from our rectangle class. So generally speaking, when you're creating and designing your class structure, your base classes should be the most generic. And then the classes you derive from your base class should get more and more specific or specialized. So in this case, as I said, squares are kind of a very special type of rectangle where they have equal sides on all four sides. But aside from that, a square is essentially a rectangle, just a special kind of rectangle. All right, so this is an example of multi-level inheritance. Forgot my L in my comment. But again, pretty straightforward. Again, single inheritance and multi-level inheritance are pretty similar, pretty easy to understand. If you understand one, you should understand the other, but kind of want to show an example here. All right, so let's move on to the next type. So the next type of inheritance I want to talk about is multiple inheritance. And now this is an inheritance structure or inheritance model where you have more than one base class. So we have a simple example here in my picture. So in this case, we have 3 base classes, A1, A2, and A3 are our base classes. And then we have a derived class B that actually inherits from all 3 of our base classes. Now, again, same thing with multi-level inheritance and multiple inheritance. The sky's the limit as to how many base classes you want to inherit from. Again, it just depends on what you're trying to achieve. You could have 15 different base classes if you want and inherit all of them into one single class. It just goes back to what you're trying to model with your code and kind of how the class structure makes sense for you. So if you want to see a quick example of this, let's see it. So we want to do multiple inheritance example. So in this case, let's say we want to do class round. And then I'm actually going to get rid of this. Actually, let's make this. Let's say 3-dimensional. All right, so we might have various methods or attributes that are attributed to 3-dimensional class or objects, I guess. But in this case, I'm just going to pass and create something called cube. So in this case, my cube is both a 3-dimensional object and it's a shape object. So yeah, so in this case, my cube class is going to inherit properties from both my shape class and my 3-dimensional class. So like, for example, if I wanted to implement something, I could have something that says volume. Create yourself, and then I'd return my computation for volume. So if I wanted to be more specific about it, I could actually have values of like how long each side is in my cube. But in this example, I'm just going to return some random value for no reason at all. But yeah, so three-dimensional would pass its volume method to its derived class, cube. So cube would be able to have a volume method that it could use. And also shape might have like a area method that it passes. I don't know. So these numbers don't really make sense. And if you think about like a three-dimensional object, it doesn't really have an area, it has surface area. So, you know, if you might want to do some extra, we'll talk more about overriding base methods, but just want to show an example where you create a base class from multiple, you create a derived class from multiple base classes. Again, the syntax of that is you have parentheses and you just use commas to separate the base classes you want to derive from. So if I wanted to add another base class, I might call it class, I don't know, cool. Maybe cubes are cool. I would just pass that in to my cube class here. So again, same thing as always. You could have as many base classes as you want. It's kind of just up to you based on what makes sense for your example. All right, so that was our example of multiple inheritance. All right, let me get rid of some of this. All right, so our final type of inheritance I want to talk about is called hierarchical inheritance. I always have trouble saying that word, but hopefully I'm pronouncing it correctly. So in this case, this is where you have more than one derived class. So kind of the opposite of multiple inheritance, where you have multiple base classes and maybe a single derived class. It's kind of the opposite. You have a single base class and you have multiple derived classes from it. So in this case, A is our base class, and B1, B2, B3 are each of our derived classes deriving from A independently. So to see an example of this, you can use my shape base class again. So we can create multiple shapes, for example, triangle, which we created before. And I can't type correctly. I'm just going to do shape. So again, triangle is inheriting from the shape class. But we could have many other shapes. So we could have something like a rectangle, which we also had before. That too will derive from the shape class. And let's add one more shape for a good measure. So let's have circle. And all right, so in this case, the shape class is a base class for all three of my derived classes that I created. Now, each of these classes derive directly from shape. Again, it's not multi-level, as in, you know, rectangle is not deriving from triangle, which is deriving from shape. Rectangle is directly deriving from the shape object, which makes sense in our example, right? Because rectangles and triangles aren't really directly related. Neither are circles related to triangles or rectangles. So in this case, it makes sense to kind of have all three be derived from our shape class instead of having intermediate classes for this example. All right, so this is an example of our, yeah, spell that correctly, hierarchical inheritance. All right, let's move on. All right, so those are the types of inheritance. Now, there's also, I guess, a fifth one, but not really. It's called hybrid inheritance. So I just named this as much chaos as you want inheritance. And so this is a sample class diagram that I've created. This could be a real world example. Again, it just depends how complex your relationships might get. But in this case, you know, we have 3 A-level classes. We have example of hierarchical inside here. We also have like multi-level from A1 to B3 to C2. Again, so you combine the 4 main types into a very complex model. Again, here we have C1, C2, multiple inheritance example for D1. But yeah, so again, it can get quite complicated. Hopefully your classes don't need to get this complicated, but you know, it just depends on what you're trying to achieve with your software solution. And just to highlight kind of what I talked about before, when you have base classes, those are the more generic classes. So just to give you kind of idea of how you want to kind of design these classes, your base classes should be more generic and your derived classes should get more and more specific. So in the example that I had before, where I had class square that derived from rectangle. So I initially had it designed this way, where square was inheriting from rectangle and rectangle was inheriting from shape. Now this, I would say, is the correct way to do it. To give a example of maybe a less correct or maybe a wrong way to do it, it kind of depends on who you're talking to. But in this case, I wouldn't want to do something like this because, let me change this up. So in this case, I kind of swap the order of square and rectangle. So I have square deriving from shape, and then I have rectangle deriving from square. So now this can work. There's nothing stopping me from actually making this work the way I want it to. But if you think about it on a conceptual level, squares are a specialized case of rectangle. Rectangles aren't a specialized case of square. Now they're both related. Like a square is a rectangle, and a rectangle can be a square, but not always. So since rectangles are more generic, it's better to have it the way I had initially. So in this case, you want your intermediary class to be kind of the more specific, but not the most specific in the example we're going with here. So that's why it makes sense to have rectangle derived from shape, because rectangle is a special kind of shape, and then square is a even more special kind of rectangle. All right, so hopefully that gives you some guidelines into when you're creating multiple classes, kind of how to structure them. Again, you go from generic being your base classes, and each derived class you create should be more and more specialized the deeper you get into the levels of derivation. All right, so let me delete that comment, not to confuse anybody, but yeah, so again, just to finalize the concept, you can combine as many types as you want into complicated relationships. You can skip levels where A3 is kind of just going straight to C3, even though C3 also derives from a B4 class. Again, there's many different relationships going on here. It's really complicated, but again, it can get very complicated. Just depends on what your software needs to achieve. All right, so that's the hybrid inheritance, basically is combining all 4 types that we talked about into various permutations. And yeah, all right, so let's talk about some more advanced inheritance topics. So the things I want to go over here are the idea of overriding properties and kind of distinguish that from overwriting properties. Again, both these words sound very similar, so I'm going to have to make sure I enunciate properly when I'm talking about both. This is terminology that I may have used before in past lectures, so I apologize if I confuse anyone since we haven't really defined what overriding means, but we're going to learn more about that going forward. Also, we're going to talk about the method resolution order in Python, short form MRO. I'm probably going to be saying that because method resolution order is quite a mouthful to say. Talk about what that is and kind of how that relates to inheritance. Also, we're going to be talking about the super method in Python. This is a useful method in classes, and we'll talk about what it does and why you should be using it. And finally, we're going to be talking about inheritance and composition, kind of talk about what both of them are. You probably have seen it before, but we're just giving a formal definition to inheritance and composition, kind of when you use one or the other. All right, so let's talk about overriding properties. So overriding is the idea of creating a new attribute or method to kind of mask something that already exists, whether it be an attribute or method. So this is where derived classes have the option to implement their own version of an existing attribute or method, but they don't have to. If they don't override something that's inherited, then it just defaults to the base class implementation. Now this is a little different than overwriting, where you're actually updating and replacing an attribute or method that already exists. So again, both these definitions are similar, so I think it'd be better to look at a coding example to kind of distinguish between both. So I'm going to go to my coding window. I'm going to create a couple of classes. So I'm kind of tired of shapes right now, so I'm going to create a dog class. And I'm going to give it a couple of methods. So let's define an init method. Don't forget your self parameter, and then I'm going to pass in name. Then I'm going to create an instance attribute of name, and assign the name there. I'm going to create a second method and call that speak, which just takes in self, and this will print out something for me. So I'm actually going to create a class level attribute, call it sound, and since this is a dog, we'll say wolf. All right, so got a pretty simple class here. I'm actually going to create another class called talking dog. And this is actually going to derive from my dog class I just created. So in this case, I've got to use parentheses and then pass in the name of the class I want to derive from. In this case, it's dog. And in this case, I'm just going to give one class level attribute. Let's say this is hello. All right, and that's all my talking dog class is going to do for now. So again, I have two classes. My dog class has a couple methods in it, has a class level attribute, and my derived talking dog class also has a class level attribute, which happens to be the same name as my dog class attribute. So let me just create a couple instances of these classes. So let's create Fido. Give that dog a name of Fido. And let's create another instance, but this can be my talking dog instance. We'll name that dog Scooby. All right, so if I call the speak method, that should print out something, and Scooby will speak us. So again, just to reiterate some inheritance topics, as you notice, my talking dog class has not implemented any methods, but we can still use the init method and speak methods because that's something we're inheriting from the dog class. So in this case, we can still pass in the name via the init method from the dog class, and we can also call speak because that method is being inherited for the talking dog class. All right, so if I wanted to run this, I'm going to bring up my terminal. I'm going to type in Python, actually a different file. All right, so let's give that a run. All right, so the output here, we got woof, which is what Fido said, and we got hello, which is what Scooby said. So again, in this case, just to highlight the topic we're talking about, so the class level attribute that I created in the talking dog class, this is actually overriding the attribute from the dog class. So this is an override because I've not actually replaced the base functionality. I'm just masking it with a class level attribute on my derived class. So this class level attribute sound gets preference over the base class, just the way classes work in Python. So when I call Scooby.speak, I'm actually using the base class method, speak method, but the sound attribute actually is the overridden sound attribute coming from my talking dog class. All right, so that is an example of overriding. Now, if you want to see an example of overwriting, that's the idea where you actually replace functionality. So, for example, this is probably bad practice, but I could replace the dog sound and replace that with, let's just say, arf. All right, so in this case, I'm actually overwriting the class level attribute for the dog class. I am not overriding it because I'm not really masking it. I'm actually replacing it entirely. So if I ran this, and all right, so now you can see Fido says arf because I've actually overwritten what was there before. So if I actually get rid of the talking dog sound, in this case, they both should say arf, which that's what happens. Again, so the reason being is because I actually overwrote what existed. So whatever exists before is gone. I've replaced it with arf instead of having wolf here. All right, so that's an example of overwriting. A good way to kind of think about the difference between overriding and overwriting is that overriding happens during design time and overwriting happens during runtime. So again, if I want to override something, I'll actually do that while I'm developing. For example, I could override the speak method in my talking dog class, and I could print out something different. So let's say we would print out, get rid of this. All right, so I've actually overridden the speak method in my talking dog class. So instead of just printing out the sound, I'm just going to actually print out something entirely different. So talking dog is going to introduce himself with his name. So if I get rid of the changes I made before, and I have my two dog instances, and let me give this a run. So I'm going to clear my screen. And all right, so if we can see the output, we got woof from Fido, because that is what the class level attribute sound value is, and that's what the speak method does. We just prints out the sound. But Scooby, however, has a different speak method. This is an overridden method. So instead of relying on the base method, we've overridden it with our own speak method on the talking dog class, and this prints out hello, my name is, and Scooby's name. All right, so again, those are just concepts that I want you guys to be familiar with. Overriding is the idea of masking and creating new functionality, versus overwriting is actually replacing existing functionality. And overwriting happens during runtime. Overriding happens more during design time. All right, so hopefully that concept makes sense now. Let's move on to the next one. So then we have something called method resolution order. So again, kind of a fancy term, short form MRO. And so this is something in Python where inherited properties, there's a predetermined order for it, especially if there's a conflict. So this can happen especially when you get more complex class diagrams or inheritance models. You can have conflicts. So the way the precedence goes is left to right ordering and upwards in the inheritance tree based on derivation. And one way you can actually observe the MRO for a particular class is by putting the full class name and then using the underscore underscore MRO underscore underscore attribute of the class. This will print out a tuple listing out the ordering for the MRO. All right, so again, this is probably better with an example. So let's go back to my coding window. Let me actually go to a new file. Let's go to MRO. Let's get in my terminal for more space. And all right, so let's do a simple example to start. Let's name that simple. All right, so let's create some classes. So I'm just going to go more generic here with my class names because I don't really want to create objects, real world objects. I'm just going to create a class A, and it's not going to have any functionality right now. I'm going to have a class B, and then actually let's have class A2. Sorry for the name changes. All right, let's go class B1, B2, and this will be a path. And then I'm going to have a class C1. Now this class is actually going to use multiple inheritance. It's going to actually inherit from class B1 and B2. All right, and right now it's going to have no functionality. So just to be clear, I have a class C1 that derives from multiple classes, in this case B1 and B2. All right. So let's actually implement a method here. So I'm just going to create a method that's called print value, and that is going to take itself, of course, because it's an instance method, and this will simply print out some generic string. So we'll do the same here. Just going to copy this, move it to my class B2, and that will print out B2. All right. So I have two classes here both with the same method name. And then I'm going to, my C1 class is just going to be empty. And I'm going to create an instance of my C1 class. So this, all right, I created an instance. Now I'm going to call C1 print value. So now let's actually think about this. What's going to happen here? We have print value both in our B1 and B2 base classes, which C1 derives from both of them. So the question I have for you guys is, what's going to be printed out to screen? Is it going to be B1? Are we going to print out B2? Or are we actually going to print out both B1 and B2 since we're calling print value and both those base classes have a print value function? So you might be thinking, hey, I have no idea what's going to happen. Luckily, Python has a game plan for this, so it's not going to be random. There's a methodology to it, and that's where the MRO comes into play. So I'm actually going to run this, and then we'll see what the output is, and we'll talk about why that was the output. So let me bring up my terminal. There's my terminal. Let's run Python MRO. All right, so I ran my program, and the output was B1. Now the question is, why was it B1, right? Why not B2? Like, is Python just guessing or randomly picking one? No, there is an ordering, and that ordering actually comes from the way you specify the inheritance in your class. So in this case, B1 is listed first, so that gets precedence in the MRO. B2 is the second one listed. If I happen to swap these, like such, now B1 is second, B2 is the first listed class for the inheritance model. If I swap those and run this again, all right, now I get B2. So again, just going back to what we talked about, let me go back to my slides. We go left to right and then upwards based on derivation. So in this case, left to right, B2 comes first in my list. So that is what gets precedence in the case where there's a conflict. All right, so it's going to search B2 first. If it finds a print value method, it'll use it. But for example, let's say this method did not exist. So let me comment that out. All right, so now this print value method does not exist. So I gotta need to add a pass here. So now if I run this, I get B1. And so the reason is because the MRO searches B2 first and looks for a print value function. It does not find one. So then it continues down the list. In this case, B1 is next in the list. So it was a print value from B1. All right, so let me just switch these to have the order that I had before. So let's B1 will get precedence over B2. And it's going to be switched back. All right, so again, that's just the way Python has defined its inheritance. It uses the MRO. It has a preset ordering, so it's not guessing. It's not randomly picking one. It's going to take the first listed item in your inheritance items, and then it's going to proceed down the line. Again, it goes left to right and upward. So if we have multiple inheritance, that's going to come into play also. We'll see an example of that shortly. So going back to my slides, let's again look at the diagram for this example. So we have B1, which is the base class, B2, and they both are base classes for C1. B1 is our leftmost class in our list. Again, we had B1 listed first, so that's our leftmost class here. So that gets priority, and then B2 gets second priority if B1 does not have whatever we're looking for. In this case, it was our print value method. All right, so this is a simple example. But as we've seen before with our class models, it can get a bit more complicated. So I have a slightly more complicated example that I've created, or that we'll create. So let's actually create this. I'll go back to that diagram, don't worry. Let's get complex tomorrow. All right, for this, I'm going to have a few more classes. So let's go A1. That's going to pass. Do class B1. That will actually inherit from A1. I have class B2, which also inherits from A1. And then we're going to have, oops, going to pass, class C1, which inherits from B1 and A1. All right, and then finally, we're going to have a class D1. Sorry for the unimaginative names. D1 will inherit from C1 and B2. All right, so again, this might be kind of hard to follow kind of mentally. There's a bunch of inheritance going on here. I created a diagram for this example. So A1, B1, B2, C1, C, and D1. We'll go back to my slides. All right, so this is the example that I just coded up to kind of see it visually, because it maybe makes a little more sense into what we created. So we have an A1 class, and we have a B1 and a B2 class that both inherit from A1. So that's these arrows right here, showing that B1 and B2 inherit from A1. Additionally, we created a C1 class, which inherits from B1, but also directly inherits from A1. So that might be kind of weird, like that, considering that B1 already inherits from A1. Why is A1 kind of jumping in there? You know, it's possible. There's nothing wrong with it. It kind of just depends on what you're trying to achieve. And then finally, we have a D1 class, which inherits from C1, but also inherits from B2. All right, so that's kind of what our class structure looks like, inheritance model looks like. All right, so let's actually go back to our coding window. And now we got to figure out what the MRO is here. So, you know, I did a more complex example to kind of illustrate how the MRO is kind of structured. So in this case, we know that C1 is first in our list for class D. So I'm going to be focused on class D1, just to be clear here, because that's our lowest, most derived class. So let me create an instance of this, D1, and that takes in nothing. All right, so in this case, what is the MRO? Again, we don't have any methods defined, but let's say, you know, each one of these classes had a method. What is our MRO? So we could try to figure out manually. So again, C1 is first in our list, so C1 would get it. But then we have B1 and A1, but then we also have a B2 in this list. So the question is, does it go left to right, or does it actually go up and keep going up? It's actually kind of both. So in this case, the MRO will be C1 first. So when we look at C1, C1 has a B1 and an A1, but actually B1 and B2 are on the same level. So if we go back to our diagram, B1 and B2 are the same level. So we're going to go left to right. So D1 is going to go to C1. C1 gets priority. And C1 is derived from B1 and A1. So B1 is listed first for C1. So B1 gets priority. But in this case, B2 gets priority before A1 gets priority. Now, I know that's kind of confusing, but we can investigate the MRO. So as I talked about, you can use underscore MRO property to kind of see that. And I'm actually going to print this out as a list because it's a little more clear. So for class name and MRO print class name. All right, so I'm just looping through the MRO, which is a tuple, and printing out the class name. So here I got to actually use the class name, not the instance. So I get rid of my instance right now. All right, so I'm using the class name and the MRO attribute on it, and I think that should look fine. I'm going to clear my screen, and then run that. All right, so I print out my MRO in order. So as we can see, the first is D1 because that's the actual class, so that gets precedence over anything else. But for example, let's say we're looking for a method that doesn't exist in D1. Where does it go next to search? In this case, it's going to look at C1 because C1 is the first class that it's deriving from in this list. So C1 gets priority. And then from there, we go to B1 because B1 is the first item for C1's inheritance. And then as we mentioned before, B2 actually slides in there because B2 is at the same level as B1. So we go left to right on the same level. And then A1 finally is the last thing that's checked. So it's, again, a little confusing. MRO isn't always that intuitive, but you can definitely investigate it and know what your class is going to do or what your classes are going to do based on your inheritance structure. All right, so again, MRO is just a predefined way for giving priority for in cases where you have conflicts with the inheritance. There's a predefined way that it'll go about searching for attributes or methods to use them. All right, so this is definitely a more complex example, but hopefully it makes sense, again, that we're just going to search locally, as in the D1 class. If we don't find something, we're going to go down this chain, C1, B1, B2, A1, until we find what we're looking for. All right, so that's kind of how the MRO works. Definitely worth more research if you're looking to understand it better or see like how better use cases. Worthwhile looking into. Again, it's a complex topic, but just understand that Python has a game plan. It's not randomly going to pick methods from your inherited base classes. All right, so that's the MRO. Now we're going to move on to the super method. So what is super? So super is a Python method that automatically calls the proper parent class. And then we're going to talk about why should you use super instead of class name. So to ensure proper MRO, as said, we just talked about the MRO. Super kind of the super method honors the MRO and ensures it's properly followed, I guess. And then also super allows for more seamless design modification. So I'm going to highlight these with examples because talking about them probably confuse you more than anything else. So let's create a couple more examples. All right, so let's create a class A1, and that's going to be a base class. We're going to create a method called print value. It takes itself because it's an instance method, and this will simply print out A1. All right, let me create another class and call that B1. And that's going to inherit from A1. And we're going to define print value again. So then we're overriding the base functionality. And in this case, we're just going to print out B1. All right, so a simple example here. B1 derives from A1. They both have the print value method defined. So in this case, it's pretty easy to understand the MRO. We're going to, if we call print value on a B1 object, we will find that print value method in this class. So we're going to print out B1 for any B1 instance. To verify this, let's quickly show that. So we'll create a B1 instance, and we're going to call B1.printValue. All right, so this should print out B1. oops, sorry, running the wrong thing. Python super. All right, so we print out B1 as expected. I don't think there's anything too magical to discover here. But let's actually extend this a bit. So hypothetically, let's say we actually want to use our base method, but also extend it. So in this case, we want to print out A1, but then we also want to print out B1. Now this is a typical use case. We could see this in real examples shortly, but let's do this right now. So one way we could do this is actually calling method via the class. So if I do something like this. All right, so what I'm doing here is actually I'm using the class and calling a method on that by passing self in. So this is in effect calling the instance method. So let me call that. So this we'll call the class method, or sorry, the inherited method first, and then I'll do the derived method logic. So in this case, I should print out A1, because I'm calling that print value function first, and then printing out B1. All right, so let's run that. All right, so I get A1 and B1 as expected. So this is where I'm going to introduce the super method, which we introduced earlier, I guess. So there's a method called super. You just call super parentheses. In this case, you don't have to pass in the self. So this is actually going to do the same thing. It's going to call the base method, and then I'm going to do my derived logic. So in this case, I should get the same output. Let me run that again. And yep, I got A1 and B1. So I think a real common question here would be, well, why do I need to use a super method if I could just, call my base class, right? Because A1 is my base class for B1. And there's a couple of reasons for it. So one thing is, what if I actually introduce a new class here? Let's call it AA1, for lack of imagination. And this will do nothing. Actually, let's actually define this here. So this class, or this instance method will print out AA1. All right, so let's say, whatever factor we design, I actually want to change this so B1 now inherits from AA1 instead of just A1. All right, well, now you can kind of see, well, I'm actually directly calling A1 here. So that's not actually going to do what I think it should be doing, which is calling its direct base class, which is AA1 in this case. That kind of makes sense? So since I've kind of hard-coded the parent class or the base class for my B1 class here, this is actually not really seamless. Like, let's say, I had like 20 different methods that was calling on the base class method for functionality. I'm going to have to update all 20 of those places since I decided to kind of hard code the base class here. So that's one highlight of using super. If I use super here, instead, I would not have to change anything. Super will automatically know that, hey, AA1 is my new base class now, or direct base class instead of A1. All right, so that's, again, one benefit of using super. Hopefully that made sense to you guys. Again, super just kind of magically knows the base class, so it will call the proper item, even if you change the base class in the future. All right. Another benefit of super is going back to the MRO that we talked about. So I'm actually going to extend my example here. Won't get too complicated, promise. Let me sort of AA1, if that was just for that example. In this case, I'm going to have a B1 class that calls its base class to print and then prints whatever it wants to. I'm going to create another base class, call that B2. That's also going to inherit from A1. And that's going to have the same exact method. But it's going to print out B2 after it calls its parent. And then I'm going to have one more class here. This will be my last class, don't worry. C1, that's actually going to inherit from B1 and B2. Print the value. And I can just have this. All right, so I have 4 classes. I have A1, I have B1, which derives from A1, B2, which derives from A1, and then class C, which derives from B1 and B2. This is what is known as the diamond design or diamond problem. If you can kind of imagine it, you have A at the top, then you have B1, B2, and then you have C at the bottom. It forms a diamond hierarchy or inheritance model. All right, so we have this. Actually, let me not keep it simple. All right, so we have 4 classes, and I have 3 methods of print value. One in A1, one in B1, and one in B2. All right, so if I create a C instance, C1, and then call C.printValue, yeah, what do you guys think the output would be here? So as we talked about for the MRO, we're gonna search left to right. So in this case, B1 is listed first, or to the left. So we're gonna go to B1. When we call print value, it's gonna go here. It's gonna call super, and then print B1. And then after that, it's gonna call print value for B1, and B1's gonna execute, and via super, it's gonna do something. So what do you guys think the output would be here? All right, so let's actually test it and then talk about it. All right, so the output here is actually A1, B2, B1. Now that's maybe not what all of you guys expected, but that is, I guess, the correct order because of the MRO. So if we actually print out the MRO again, like we did before, so let me do a for loop, class name as my variable, in C1 in my class, and do double underscore MRO. And let's just print out the class name. All right, I think I have that coded correctly. Let me bring up my window, just tab. All right, so if I run this, all right, so let's look at our MRO here. So again, this is going, it's kind of reversed, but A1 is the least, I guess, least significant. So C1 gets first priority, then B1, then B2, and then A1. So that's kind of reflected in the calls here. So B1 is the last thing printed because, actually, let me just switch this. Sorry, should have done this way. Sorry, so the derived method is going to print what it wants first. Now it's going to kind of flip what we have. Just this. Clear that. All right, so now we have B1 at the top, B2, and then A1, which kind of reflects the way I'm printing out the MRO classes, B1, B2, and A1. So let's talk about this. So what's actually happening here is when we call super from our B1 method, that's not actually calling A1 like we would have expected. So it's actually calling the B2 method. Because you notice we print out B2 here. The reason being is because in the MRO, B2 comes after B1, right? So if we look at our MRO down here, we got C1, B1, B2, and then A1. So super kind of magically just knows that B2 is next in the ordering. So it will call B2's print value when we call super.print value. All right, so if we actually didn't use super and we actually put in A1 here, and we got to pass in self in this case. So now instead of using super, like we should be doing, we're calling our base class. So this is actually just gonna totally ignore B2, even though B2 has, precedence here before A1. So if I clear this, all right, so in this case, we only print out B1 and A1. B2 kind of just get left out of the equation. Now, again, that might be what you want to do. So again, it comes down to case-by-case basis, but normally you want to maintain the MRO. So for example, if we're calling, if we're calling print value here and trying to get to our base, in this case, the next base class is B2 in terms of C1's inheritance model. So super, again, instead of calling A1, even though A1 is the direct base class for B1, it's going to know that, hey, for C1's purposes, B2 is actually next in line for a base class before A1. So if I change this back to super, like I just did, again, that'll print out, sorry, don't need a self here. All right, so again, in this case, I call print value on the C object. So C looks in B1, because B1 is the leftmost inherited class. B1's print value will print out B1, which is what we got. Then it calls super, which basically goes to the next class in the MRO. In that case, it's B2. B2 prints out what it wants to, and then calls super. And then A1 is next in the MRO. So A1 eventually gets called, but not before B2 gets to print out what it wants to. All right, so again, that's kind of looking at the MRO and understanding why super is preferred than hard coding in the base class. Again, one, your design might change, and then you got to update all cases where you use the base class name directly. And two, to ensure proper MRO honoring, you want to use super as opposed to just calling the base class directly in this case. All right, so again, super keyword, it just kind of automatically will do the right thing for you in terms of the MRO. That's why it's preferred to use that instead of using the class name. All right, let's move on. The final thing that I want to talk about is inheritance versus composition. Again, this is something that you guys might have already done before and encountered, but I just want to give a more formal definition to it. There are cases where it can kind of become confusing which to use, but inheritance is used for is-a relationships. So examples I have here is a dog is a type of animal, right? So if I were creating a dog class, I would derive it as in use inheritance from the animal class. So if I was, let's kind of get that going here. So if I have class animal, for example, that doesn't do anything, and class dog, in this case, I would inherit from my animal class because a dog is a type of animal. All right. Likewise, like example we saw before, a square is a shape. Therefore, if I had a square class and a shape class, I would derive my square class from my shape class. All right, so we saw that before also. Composition is a little different. Composition is for has a relationship. So, for example, a dog has a name. So let's say, for example, for example purposes, I had a name class. All right, name, and this maybe, let's say I had a couple attributes. So let's say, just jazz it up, got first name, first name and last name. So that's what my name class kind of holds. All right, so last name and first name. All right. And nothing fancy going on here, but just for this example, let's say I have a name class instead of just having one attribute for name. All right, so so if I wanted to do this, one way that I could do it is inherit from the name class. So let's say I chose to do this, and then let's not do it in there. So if I had this modeling where I have a name class and I inherit from the name class for my dog, this totally works as I would expect it to. So if I have a dog instance, I'll give it a first name. Let's call him Scooby, and last name Do. All right, so in this case, if I wanted to print out Scooby's name, just name them a little better, Scooby.first name plus Scooby.last name. Let's put space in there. All right, so I'm just gonna print this out, just have some visuals. Print Scooby.first name and Scooby.last name. All right, clear my screen. Let's run Python composition.py. All right, so I got my output Scooby-Doo. All right, so I'm kind of looking at this and I'm like, all right, I have a dog that takes in a name. This works exactly like I would expect it to. What's wrong with this? So it goes back to the idea of composition versus inheritance. So again, inheritance is a relationship. Composition has a relationship. Again, this can get murky. Like you can maybe rephrase your sentence and say a dog is something that is something that has a name. Like that's not an is a relationship still. You could try to mangle your English to kind of convince yourself of is a relationship, but again, it can get confusing at times. These aren't the greatest examples for like where it's ambiguous, but I just want to highlight that you can still use inheritance and get the results you want, but that doesn't mean inheritance is always the right design. That's the thing I'm trying to clarify here. So this works, but if I'm looking at this objectively, dog is not a type of name. All right, a dog actually has a name, but it's not a type of name. So in this case, inheritance is the wrong choice. Again, it works for what I want it to do, but it's still not the proper design. So the proper design in this case, I'm just going to ignore the animal class right now, just to keep it simple. The proper design in this case would just be have a dog class, and then inside my dog class, I want to have an attribute that is of the name class. All right, so let me kind of highlight this, do self, and then I'll actually pass in the name. and that's going to be a name class object. And I'll store that as a instance attribute. So name equals name. So this is maybe more familiar to what we've done before, but this name is actually going to be a name object. All right. So in this case, let me break this apart. Probably shouldn't have deleted that. All right. So I'm going to do dog name. And I'm going to create a name instance and pass in the values I had before. And now I'm going to take that instance that I created of the name class and pass that in just like before. However, now I'm actually storing the name object as an attribute. And the reason being is because a dog has a name. A dog is not a name. Hopefully that distinction is clear. So in this case, a name is a kind of an attribute of a dog. It's not really what a dog is. Does that make sense? So again, you can totally make it work with inheritance, but that doesn't mean inheritance is the right way to do everything you want to do all the time. So in this case, this is called composition, where you're kind of nesting classes within each other. So the dog class actually has a nested name object, which you could have multiple classes nested. You probably saw them with some past assignments or coding challenges from previous nights. But yeah, so that's composition, where you're actually storing attributes of different classes as members as opposed to inheriting from classes. All right, so that's the distinction between inheritance and composition. Again, know the difference and kind of understand when to use one or the other. All right, so that kind of wraps up all the inheritance topics. I want to just go with some key takeaways. Obviously, the first key takeaway, hopefully, is know what inheritance is. Again, that's the mechanism within OOP where we can pass properties, whether it be attributes or methods, from base classes down to derived classes automatically. Know the different types of inheritance models. So we have single inheritance, where one base class or one derived class kind of inherits from one base class. We can also have multi-levels, so that can chain. You could have a base class, then a derived class, and then a more derived class in a chain, and go as long as you want. You can have 5 levels deep, 20 levels deep, as far as you want, if it makes sense for your software solution. We also have multiple inheritance. That's the idea where multiple base classes can kind of derive down to one class. Common example, again, we have 2 parents. So we have mother and father. They pass traits to us. So that's an example of multiple inheritance. We can also have hierarchical inheritance, and that's where you just have one base class but create multiple derived classes from it. So in the example we had before, we had a shape base class, and then we had several derived classes like triangle, rectangle, and circle, which were all directly derived from the shape class. All right, and again, keep in mind you can combine multi-level with multiple inheritance with hierarchical, like you create complex inheritance chains. It just hopefully it still makes sense when you're doing it. You shouldn't just do it just for chaos sake. Your model should make sense in terms of why you're inheriting from one class or multiple classes. All right, know how to use inheritance in Python classes. So this, again, just going back to the syntax, you create a base class, you create a derived class. If you want to inherit from the base class, you will pass it in parentheses for the class definition. So we saw that where you have like class B2, you parentheses, and then A1 if that's your base class. You can have multiple base classes, so you separate those by commas in the parentheses list. And finally, the last thing I want to highlight is know the difference between class inheritance and class composition. I've definitely kind of mixed up the design for both. Sometimes I've used inheritance where it was wrong. Through the process, you kind of understand why composition is used in certain cases and kind of make sure I don't make that mistake as often. But again, it can get confusing depending on your use case. Sometimes is-a and has-a isn't that distinct. You could be like, all right, well, this could be a is-a or a has-a. Which one's right? Again, it comes down to what you ultimately determine based on designing your code. The other topics we talked about, again, I don't want to focus on too much as key takeaways, but MRO, understand at least what that is and kind of how that's implemented in Python. Also understand overriding versus overwriting. Again, these are just more concepts that you might encounter in your software development in the future. All right, so that was our lecture on inheritance. Hopefully you guys kind of learned why inheritance is important and how it's useful in our development practices. All right, thanks a lot, guys.